Hello my dear friends, I am Shubham from LearnoHub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So friends, as you all know, we are studying your ICSE chemistry chapter number 3, study of acids, bases and salts, right? And now in this video, we are going to see what are actually acids, their definition and classification of acids. Okay, so without wasting much time, let's start and let's rock. Okay, so now before starting to learn this chapter, acids, bases and salts, let's see why actually we should learn acids, bases and salts, right? So I definitely know you would be knowing these creatures on the screen, right? If you would by mistake you would leave some sugar candy or sugary syrup on the floor, you would definitely find them. And these hard-working ants, they don't even leave any chance to bite you. Okay, so when this ant bites us and we experience that ant bite, it's really painful. It's irritating to us, right? The skin, that part on the skin where we experience that ant bite, it's irritating, right? Now, if I would tell you that I'm having a solution for this ant bite irritation, okay, so it would be interesting for you to know, right? So what you do is simply next time when you experience an ant bite, go to your mommy, ask her for baking soda. It would be in powder form. So remove that powder, quickly make a paste of that powder by adding some water and apply that paste on your skin. Okay, so what would happen? You would feel the relief. Okay, now what actually happened is this baking soda, which is sodium bicarbonate, NaHCO3, it's a salt, but this salt is reacting with the acid, okay, which is the formic acid, which is injected by the ant in our skin. That's why we are feeling that irritation. And this baking soda, salt, reacts with that acid, formic acid, okay, and some reaction takes place and this formic acid is used up. So we feel relief, right? So like this, there are so many applications of acids, bases and salts. Okay, for example, to tell you very quickly about acids, one example is vinegar, acetic acid we use in cooking, right? Next one, base, NaOH, sodium hydroxide, we use it for making soaps, okay, very important. And for the salt, I don't think I need to tell you an example because you already know it, sodium chloride, table salt. Without it, our food would taste very bad, right? You won't eat actually. So such important applications of acids, bases and salt exist and we are using them in our day-to-day life in a wide scale, okay? So wouldn't it be interesting for us to study about them first, because then only we can use them efficiently in our day-to-day life, okay? So I think now you are feeling interested and convinced, so then let's start. Okay, so before moving ahead, so that we could start studying or start learning about the acids and their classification, bases and their classification, salts and their classification, okay, so we are going to use these two terms, ionization and dissociation, okay, very frequently. Now we have already studied these two terms in your previous chapter, chemical bonding, okay, but in this chapter now since we are going to use it very frequently, so we are going to just quickly revise it, what actually they are, so that you won't feel confused within them. Okay, so first is ionization. Now we know process of formation of ions from molecule, right? We have studied it in the chemical bonding in this way. So actually it's the same thing, right? We are just going to revise it. So it is a process in which neutral molecule, okay, is splitted into charged ions in the solution. Like we have seen HCl, right? It is a neutral molecule. Now when we are making the solution of HCl, which means we are adding water into the HCl, what is happening? This HCl molecule is splitting into, see, this neutral molecule is splitting into charged ions, okay, in solution. So it is splitting into H plus and Cl minus. Okay, now what actually is happening here? This H plus is so reactive, okay, in water. So it cannot exist independently. It like jumps here and there and says, oh, I want someone with whom I can just react. I cannot leave as it is right now. So this H plus, then we have already studied, this oxygen atom of water, okay, forms coordinate bond with H plus, correct, in the previous chapter, and they form H3O plus, okay. So this oxygen, so this water molecule says, oh, H plus, come here, we will form a bond, okay, and then whatever reactivity you are feeling, you would be calmed down, okay. So in this way they form H3O plus. We already know how it is formed, right? And this Cl minus is as it is, okay. So actually what is happening, this neutral molecule is splitting into charged ions, okay, in the solution, and this is called as ionization. Very clear. Now moving on to HNO3, the next example, it also dissociates, ionizes, okay, in the same way. HNO3, water, this H, okay, would leave, okay, and this NO3 here, it's a negatively charged ion, okay. So what would happen, this NO3 would be here, this H would leave as H plus, it would get combined with water and it would form same H3O plus, like in the same way in case of HCl, okay. So this HNO3 has also splitted into charged ions, H plus and NO3 minus, okay. Later on that H plus is getting combined with water, okay. So that's the other thing, but our main thing is it is getting converted into charged ions, okay. The neutral molecule is splitting into the charged ions in the solution, okay. Now dissociation is, it's very simple, it's just the process of separation, okay, process of separation of ions in water, okay. Ions get separated in water and these ions are already existing, okay, in the solid state of the substance, okay. So now we have already studied ionic compounds, correct? So example is NaCl, okay. Let's understand this with the help of example. NaCl, okay, in this NaCl we know Na plus ions are present, Cl minus ions are present, correct? What is happening when we are adding NaCl in water, okay, in water? So I just write here aqueous to denote that I have added it in water. So what is happening, this Na plus and Cl minus ions are getting separated, okay. How they are separated? In this way, Na plus Cl minus, okay. Now since they are present in water, I am writing here Aq, okay, aqueous, to denote this thing. So what has happened, see, process of separation of ions in water, correct, already existing as such in the solid state of the substance, and these ions are already existing as such in the solid state of the substance which is added in the water, okay. So example we have seen NaCl, same case goes with NaOH as well, okay. This NaOH, when we add it in water, what is happening, it is getting dissociated, okay, it is getting separated, the ions are getting separated, Na plus and OH minus ions are getting separated in water, okay, which they are already existing as in the case of the solid substance. Here NaOH is a solid substance, okay. So in this solid substance Na plus and OH minus ions are existing, okay. Now let's first start with the definition of acids, okay, and then we are going to see the classification of acids, okay. So first, actually what are acids? Acids are simply the compounds which releases hydronium ion. Now we know what is hydronium ion, H3O plus, correct. This ion they are releasing as the only positive ion when they are dissolved in water, and such compounds are called as acids. Very simple, okay. So let's understand this definition with the help of examples. So these are examples of some acids, okay. So out of this, first let's take HCl, we already know, okay. So this HCl, when it is dissolved in water, so I'm adding this HCl in water, what is happening, okay, they are releasing hydronium ion, H3O plus. Now we already know this thing, we have seen in the previous slide, right? They are releasing hydronium ion as the only positive ion, correct? Yes, and the rest is chlorine minus ion, okay. Now in the same way, HNO3, just now we have also seen this example, when they are dissolved, when HNO3 is dissolved in water, this compound is dissolved in water, it also gives us H3O plus and NO3 minus, okay, in the same way like that of HCl. Now let's take the example of H2SO4, third one. How H2SO4 gives us the hydronium ion? So when it is dissolved in water, what is happening is, see here these compounds HCl and HNO3 have one hydrogen, okay, and these were willing to give that one hydrogen to water molecule, okay. So we call such hydrogens as ionizable hydrogens, okay. Ionizable hydrogen. Why I'm saying it ionizable? Because these hydrogen atoms are released by the particular compounds to form H plus ion. That's why ionizable, right? Now, here in case of H2SO4, it is having 2 hydrogen atoms, and yes, H2SO4 here is readily willing to give up 2 H plus ions. Okay, so it is readily willing to give up its 2 hydrogen, and these hydrogens are getting converted into H plus ions. Okay, so it is having now, so this means it is having 2 ionizable hydrogen atoms. Now these 2 ionizable hydrogen atoms need 2 water molecules, right? So here I have taken 2 water molecules. Now what would happen? These 2 water molecules, one water molecule will combine with 1 H plus, it would form 1 H3O plus. Another water molecule would combine with other H plus, it would form another H3O plus, right? So 2 H3O plus would get formed. So I'm writing here 2 H3O plus. Okay, now what is remaining? See here, SO4. Okay, now we know that SO4 is a polyatomic anion. Okay, poly means many, atoms means many atoms, and anion which is because it is having a negative charge, and it is having 2 minus negative charge. So SO4 is getting liberated also in water. Okay, now what you can do is, after writing the ionization equation for acids, okay, you can just check in the products whether the charges are being balanced or not. See here, H3O plus, 1 plus charge, 1 minus charge, 1 plus charge, 1 minus charge. Okay, so charges are balanced in these cases. Here see, 2 plus charges, 2 minus charges, so charges are balanced. So that case, so in that way you could understand that, oh, you have written the right equation for ionization. Okay, now I have given this single headed arrows. Okay, single arrows. Now why is this so? There is a difference between the single arrow, and now I'm going to use the double headed arrows in this. Okay, so let's understand why is it. So first we have seen these 3 examples. Now moving to H2CO3 and CH3COH. So here H2CO3, okay, when we are adding it in water, what is happening? I'm writing this double headed arrows. Okay, one arrow is half the way cut off, it is heading ahead. Another arrow, it's half the way cut off, it's heading in the opposite direction. Okay, now what's the difference here? See, these compounds, now we know that they are acids because they are releasing hydronium ions, and these compounds dissociate, these compounds ionize completely, sorry. Okay, these compounds ionize completely into their ions, right? So that's why, since they are completely ionizing, we are using this normal arrow. Okay, and such acids, okay, which ionize completely, okay, in water are called as strong acids. Okay, strong acids. Now the case with this acids, H2CO3 and CH3COH. Okay, these acids do not ionize completely in water, which means that they are not, their molecules, their neutral molecules are not completely splitted into their charged ions. Okay, some neutral molecules remain as it is in the water. So in this case H2CO3, some neutral molecules of H2CO3 remain as it is in the water molecule. Some neutral molecules, okay, of H2CO3 would get splitted up into charged ions. Okay, so which charged ions it would get splitted up? Same logic we are going to use. See, it is having here 2 hydrogen atoms. Okay, now these 2 hydrogen atoms, this H2CO3 acid is willing to give. Okay, so we can say that they are ionizable hydrogen atoms. So then the same case like H2SO4, right? 2 H plus ions would be there here also. So 2 H plus ions. Now these 2 H plus ions need 2 water molecules. So here I have taken 2 water molecules. Then what would they form? They would form H3O plus. So each H plus ion would combine with water, form H3O plus. This also would form H3O plus. So 2 H3O plus would be formed. So 2 H3O plus. And what is remaining now? CO3. Okay, this is remaining. Now we know that this is also a polyatomic anion having charge 2 minus. Okay, so this would also get formed. Okay, now balance the charges, 2 plus 2 minus. Yes, it's correct. In this way, this H2CO3 is getting ionized. Okay, and it is a weak acid. Now in the same way, our CH3COH is also going to ionize. So let's try. You try on yourself. You just pause this video here. Try how the CH3COH gets ionized. Okay, on your own. You have to use this double-headed arrow because it is a weak acid. It won't get ionized completely. Some molecules of CH3COH will remain as it is in water. Only some molecules of CH3COH would get ionized, would get splitted up into charged ions. Okay. Now let's start. So what would happen here? This CH3COH, as you can see here, 4 hydrogen atoms, but won't give 4 H plus ions, right? It is only willing to give this H plus ion, only this. Rest 3 it won't give. So this means that this H plus ion, it is only 1, so it would combine with this water molecule and it would form only 1 H3O plus. Okay. Now remaining would be this CH3COO, this part. Okay, and we call this part as acetate ion. Okay. Don't worry, no need to remember this right now. Okay, hard and fast you can remember it. Okay, but we are going to learn it in the organic chemistry as well. Okay, so you better remember it, it would be good for you only. So CH3COO, and this acetate ion has a negative charge on it, a single negative charge. So see, now here the charges are getting balanced, plus and minus. Okay, so maybe you would have got wrong while writing the ionization equation for this acid. So what thing you have to keep in your mind, that a particular acid, it's not necessary that it would give up all of the hydrogen atom it has. Okay, there may be some hydrogen atoms which that acid won't be giving up. Okay, so this means that the ionization process depends not only just on the number of hydrogen atoms, okay, in that acid, but on the number of ionizable hydrogen atoms. Okay, which hydrogen atoms that particular acid is giving, means particular acid is willing to give up. Okay, now moving ahead to the classification of acids. So acids, here we are going to study the 2 classifications. First is based on the source. Okay, so acids are classified based on their source in two types: organic acids and inorganic or mineral acids. Okay, now what are organic acids? So such acids which are obtained from plants, okay, are organic acids. What are mineral or inorganic acids? These are the acids which are obtained from minerals. Okay, so acids which are obtained from minerals are called as mineral acids or inorganic acids. Very simple. Now these organic acids, they have important characteristic, they have carbon atom in them. Okay, while inorganic or mineral acids do not have carbon atom. But the exception here is H2CO3. See, H2CO3 is a carbonic acid. Its name is carbonic acid. Okay, so you can remember as like this. See here, CO2 molecule. See, it's CO3. Okay, but you can just figure out CO2 from here. Okay, out of this CO3, just forget about one oxygen. So what would remain? CO2. And CO2 is carbon dioxide. So you can remember in this way: carbon dioxide, then carbonic acid. Okay, in this way you can relate it. So this acid, it is having a carbon atom. Okay, but it is actually a mineral acid. So this is an exception. Now these organic acids are weak acids. So we have already studied about it, right? Weak acids are those acids which ionize, which do not ionize completely, okay, in their solution. So this means that some molecules of these organic acids, okay, they remain as it is in the water. Okay, is as it is, and some molecules of these organic acids, they split up into the charged ions. Okay, so what does this is indicating us? See, weak acids, I have told you, some of the molecules won't ionize, some of the molecules would ionize, okay, or some of the molecules would split up into charged ions. So see, so that means that some molecules would be as it is and some would be splitting up into charged ions. So in this solution we would find both molecules as well as ions, okay, in the solutions of weak acid. Okay, so you have to add this point where we learned about the weak acid, okay, in the previous slide. And in the case of strong acids, we know they ionize completely, which means all the molecules of strong acids, they split up into charged ions. So their solutions, okay, won't have any molecules left. There would only be charged ions in their solutions. Okay, so this point you have to add in the previous slide. Okay, same like that of the weak acids point. Now here, inorganic or mineral acids are strong acids, right? But exception here again is H2CO3. We know, we have studied in the previous slide only that H2CO3 is a weak acid. Okay, and examples. Now organic acids, examples are acetic acid. Okay, we also call it as commonly as vinegar. Okay, which we use in our which mom uses in kitchen, right, to make food. Now this acetic acid is having formula CH3COH. Now we have seen its ionization, right? It is only willing to give this one hydrogen atom, so it is a trickier one, right? Now oxalic acid, another example. So COOH twice. Now let me simplify this formula for you. Okay, in this way, its formula is this: COOH. Then there is a single bond between the carbon atoms, and then again COOH. Okay, so here these two hydrogen atoms are ionizable. Okay, and in case of formic acid, right now, have you clicked anything by reading this formic acid word? Ant injects formic acid in our body, right? I have told you. So here comes formic acid. It is only here, this acid is only willing to give this hydrogen. Okay, so it has only one ionizable hydrogen atom. Okay, same way inorganic and mineral acids examples are HCl, H2SO4, HNO3, H2CO3. Okay, HCl is hydrochloric acid, H2SO4 is sulfuric acid. Okay, this is nitric acid, and I have told you this is carbonic acid. Okay, sulfuric acid and hydrochloric acid. Okay, and we have seen the ionizations of all these acids. Okay, now let's see the second classification of acids, okay, which is based on basicity. Right, now what is this basicity? So basicity of any acid, it's very simple. It's just the number of H3O plus ions, which means the hydronium ions produced by the ionization of one molecule of that acid in aqueous solution, which means when we are putting that acid in the water. Okay, so how many H3O plus or hydronium ions that particular acid is producing by the ionization of its one molecule. Okay, so seems pretty confusing, right? Let's make it simple with the help of example. So here, see, I'm taking HCl. Okay, now this acid, when I'm adding it into water, okay, so I'm making its aqueous solution first of all, right? Now it is giving me, I know, hydronium ion and this Cl minus ion, chloride ion. So how many hydronium ion I have got? One, right? So the number of hydronium ion produced by ionization of, see here, the HCl is getting ionized, right? We all know from the neutral molecule is splitting into the charged ions, right? H plus and Cl minus. So the number of hydronium ions produced by the ionization of one molecule of acid. See, ionization of one molecule of acid in aqueous solution. So how many hydronium ions? One hydronium ion, right? So the basicity of HCl is 1. Very simple, correct? Now it also, so basicity, this is the trickier thing. Okay, we will see its example, then we would understand that basicity of an acid depends on the number of ionizable hydrogen atoms. We have already seen this thing, but just we are going to correlate with the basicity part. Okay, in a molecule of an acid, in one molecule of an acid, and not just on the number of hydrogen atoms present in that one molecule of acid. Okay, so let's see this when we see the dibasic acids. So first of all, we have understood what is basicity, correct? Now based on the basicity, acids are classified into 3 types: monobasic acids, dibasic acids, and tribasic acids. Okay, now what is monobasic acid? It's simply that those acids which are having basicity 1. Dibasic acids are the acids which are having basicity 2. Tribasic acids are the acids which are having basicity 3. Okay, so we can simply tell this in this way, or if you want to define them very clearly, so the definition is also very simple. You have to just remember the definition of basicity of acid, which we have already now seen. So monobasic acid, so which acid is a monobasic acid? The acid which gives us one H3O plus ion, okay, by the ionization of its one molecule in aqueous solution. We can make the definition, right? Dibasic acid, the acid which gives us 2 hydronium ions by the ionization of its one molecule in aqueous solution. And same goes with the tribasic acid, the acid which gives us 3 hydronium ions by the ionization of its one molecule in aqueous solution. Okay, so very simple definitions. You have to just remember the definition of basicity and then you can make the definitions for all these three types of acids. Now, important thing is we have to understand them with the help of examples. So how such acids which we are going to see right now, the examples of those acids, how they are monobasic, okay, by looking at the ionization equations. So first let's start with the monobasic acid, examples of monobasic acids. So just now we have seen one example, HCl, correct? Like that we are having another examples like HBr, HI, okay, HNO3, CH3COH. Okay, now you know the name of HCl is hydrochloric acid. Similarly, the name is similar, okay, in similar fashion, hydrobromic acid. Okay, then of HI is hydroiodic, right? Iodine, right? So hydroiodic. Then you know HNO3 is nitric acid, CH3COH is acetic acid. Now, just like how HCl is ionizing and giving us one hydronium ion, okay, that's why its basicity is 1. Very simple. So in the same way, HBr, HI, HNO3, CH3COH, all of them ionize, okay, in their aqueous solution and they give us one hydronium ion. But now, I have told you this thing, it depends on the number of ionizable hydrogen atoms in one molecule of acid. This we can understand with the help of CH3COH, right? Here, okay, in all these cases, how we have to write the ionization equations? It's very simple. All these things would be same, okay. In case of HCl, in place of HCl, it would be HBr, HI or HNO3, okay. Now water we would add, we would get hydronium ion, one hydronium ion, and just the negative ion would be different. In case of HBr, it would be Br minus, okay. In case of HI, it would be I minus. In case of HNO3, we know, we have already seen, it would be NO3 minus, okay. Very simple. Now let's see the CH3COH part. We have already studied its ionization equation as well, okay. How it ionizes? It just allows this hydrogen atom to leave as H plus, okay, and then this hydrogen atom as H plus goes to water, right? Since it is a weak acid, okay, so we are showing this double-headed arrow. It goes to water and forms H3O plus, okay, hydronium ion, and the remaining part is the negative ion which is formed, CH3COO minus, okay, acetate ion. Now in this, see, there are 4 hydrogen atoms, I have already told you, but out of them only one hydrogen atom is going to H2O. It is saying let's make a bond, let's form H3O plus. So this means that, see, one hydronium ion is formed, so basicity is 1. Now here basicity is depending on the number of ionizable hydrogen atoms, not on the total number of atoms, total number of hydrogen atoms, right? You're getting the point? So that's why basicity depends on the number of ionizable hydrogen atoms in one molecule of an acid, okay. Here in this case, ionizable hydrogen atom is 1, okay. So it is only forming one hydronium ion and therefore basicity is 1. And not just on the number of hydrogen atoms. Here number of hydrogen atoms are actually 4, but hydronium ions which are formed is only 1, right? So it is not depending on the total number of just the hydrogen atoms. And one last thing before moving to dibasic acids, we have just now seen the examples of monobasic acid, right? HCl, HBr, HI, HNO3 and CH3COH, right? Okay, so we know how to write the ionization equation for HCl. We have already studied this, right? HCl plus water gives H3O plus plus Cl minus, and I have already told you how to write the ionization equations for HBr, HI and HNO3 as well. What you have to simply do is, here in place of HCl it would be HBr, HI or HNO3, okay, and this would be same, plus water plus water plus water, okay. The arrow, yes, the arrow would be normal arrow in all these cases. Why? Because these, we know that HNO3 is a strong acid, but this HBr and HI are also strong acids, so they would also ionize completely, okay. So therefore we are showing the normal arrows. This would be same, it would all form one H3O plus. How? Their one H plus would go and they would combine with water molecule, they would shake hands with water molecule and form H3O plus. We know how H3O plus is formed, okay. So one H3O plus is formed, that's why their basicity is 1, right? We know. And just what would be the difference here? The negative ions would be different. the Br, here Br minus would be there in case of HBr, in case of HI, I minus, in case of HNO3, it would be NO3 minus. Okay, now what you do, you pause here and you try to write the entire equation on your own, okay, so that you would get a practice, because until and unless you write, you won't find the mistakes where you are going wrong. Okay, then about CH3COH, I have already told you, it has a double-headed arrow because it is a weak acid. It is not getting ionized completely. Okay, and we have already seen its ionization equation as well. Okay, now let's see the examples of dibasic acid. Okay, so we already know what is dibasic acid. It is having basicity 2, which means that it is producing 2 hydronium ions by the ionization of one molecule, okay, of its one molecule in aqueous solution. Very clear. So examples are H2SO4, this is sulfuric acid, okay, we already know this. H2SO3, okay, so this is, you can say, bhai of H2SO4, a brother of H2SO4, right? Sulfurous acid. Okay, just one oxygen is less than that of the sulfuric acid. H2SO4, H2SO3, sulfuric, sulfurous. Very simple. Then H2CO3, we already know this is carbonic acid, right? H3PO3. Okay, now this is, I think you would have guessed its name, phosphorus acid. Okay, same like sulfurous. Okay, see, sulfurous, H2SO3, H3PO3. Here SO3 and PO3 are same, so you can remember in this way. SO3 is sulfurous, so PO3 is phosphorus. Okay, so phosphorus acid, and you know this acid, COOH, twice oxalic acid. Okay, now these are the examples of dibasic acid. Now how they are dibasic? So first we would see the ionization of H2SO4. Then we would understand that yes, it is giving 2 hydronium ions, and we already know it gives 2 hydronium ions. How? See, 2 water molecules, we have seen its ionization. So 2 H plus are getting produced. So here 2 water molecules are needed. Okay, 1 H plus goes to 1 water molecule, produces H3O plus. Another H plus goes to another water molecule, produces another H3O plus molecule, another H3O plus ion. Okay, so there are 2 H3O plus now. So here 2 H3O plus. Now what is remaining here? SO4. So I have told you SO4 is formed as SO4 2 minus. Okay, polyatomic anion. SO4 is having 2 minus charge. So this is the ionization equation for H2SO4. But this ionization actually, it takes place in 2 steps. Okay, let's see those 2 steps. So here first step is H2SO4 plus first water molecule. Okay, what is happening now? Well, when we are showing the ionization, okay, in 2 steps or 3 steps, so we would use this arrow, okay, the double-headed arrow. So here H2SO4, now it gives off 1 H plus in first step. This 1 H plus is catched by water molecule, okay, and it forms H3O plus. And what is remaining? There, it is very easy to write the ionization equations. You have to just apply the logic. So I know H3O plus is going to be formed. Here in the first step, 1 H plus is going to be lost. Okay, so this H plus, this water molecule forms H3O plus. Now what is remaining? See, 1 H is gone. So 1 H and SO4 is remaining. Okay, so I'm just writing here 1 H and SO4. Okay, now very simple, I have told you a trick. What you have to do? You have to just balance, okay, the ions which are formed. So here H3O plus, 1 plus charge, right? So it would be 1 minus charge. In this way also you can remember, or else you know that SO4 is 2 minus, right? 1 H plus would with it, what would happen? See, SO4 is 2 minus. When it is along with 1 H plus, okay, so the positive and negative charges would get balanced, right? So 2 minus and 1 plus, we all know integers, minus 2 plus 1 is minus 1. So HSO4 would have minus 1. So this is a simple trick, okay, in order to find out the charge of that particular polyatomic anion. So in this way, it's the first step of ionization of H2SO4. In second step, what would happen? See, here 1 H3O plus is formed. Now second step, this would again come back in role, okay. This HSO4 minus ion, it would again get ionized, okay. Now this way, in this case, this H plus would be gone now with the water molecule. It would form H3O plus, right? So what would be remaining now? SO4, correct? now we know this H plus has lost. Okay, so in HSO4 minus there is one H plus. If it is gone, right, if it is gone, SO4 2 minus would form, right? And we also know SO4 has having 2 minus charge, so you can directly write here also. Okay, without applying the trick, you can just remember SO4 has 2 minus charge, so it would be correct. Okay, now what would happen? See, here you would say, oh, now the charges are not balanced here. See, plus 1 and minus 2 is minus 1, correct? So on this side of the equation it's minus 1. Now we have to also see, again, if we are finding some charge, we have to see that whether on this side of the equation there is same charge or not. So see here, it's 0, it's minus 1. So here also it is minus 1. So then our equation is correct. Okay, if you're finding some charge here, okay, after balancing the charges, then just have a look on the other side of the equation whether it is having a charge or not. If it is also having the same charge, then it's absolutely fine, because these two charges will get cancelled. Okay, now when you would see the net reaction, okay, now I have told you how to get the net reaction when we are studying chemical bonding. So I would again tell you once again. So this two species, whether you are able to find out here, okay, if you are able to find these two species here, then you have to cancel it. So see, H2SO4 water molecule, no, I'm not getting anything here. Okay, then these two species I would try to find out them, okay, in the other equations opposite side. So HSO4 minus H2, HSO4 minus H2, see, I have got HSO4 minus. Okay, so I would cancel it. If I'm getting same terms, I would cancel it. Now I would write the entire equation, okay, net equation. So what it would be, H2SO4, see, H2SO4, then on this side two water molecules, and then H3O plus, H3O plus, 2H3O plus, see, okay, and here what is remaining, SO4 2 minus. So net reaction would be this. So I hope you would have understood how H2SO4 ionizes in 2 steps, and net is this only. Okay, so we have just bifurcated this one step into 2 steps to show how it is ionizing, okay, step by step. Okay, so now we just now saw how H2SO4 gave us 2 hydronium ions. So its basicity is 2, so it is an example of dibasic acid. So in the same way, this H2SO3, H2CO3 and this oxalic acid, okay, this is sulfurous acid, carbonic acid and oxalic acid. These acids also give us 2 hydronium ions, okay, therefore they are also dibasic acids. Now how they give 2 hydronium ions? Okay, let's see their ionization equations. So just like H2SO4, their ionization equations are exactly the same. Okay, so for example, I am seeing H2SO3's ionization equation, okay, H2CO3's. So both this I would show the ionization equations in one go, okay, because they are going to ionize exactly in the same fashion as that of H2SO4. So they would also require 2 water molecules, because 2H plus would be produced, means 2H plus would be going away from this H2SO3 and H2CO3. Okay, they would result into 2H3O plus. Okay, now we know how they are getting formed. Okay, and along with that, what would happen? Remaining would be SO3, right? SO3. Okay, now you should remember this SO3 is having 2 minus. It is also having 2 minus charge, just like SO4. Here CO3, it is also having 2 minus charge. Okay, carbonate ion. Okay, now just the difference is, see, H2SO3 and H2CO3, sulfurous acid and carbonic acids are weak acids. Okay, so they won't ionize completely. Therefore, the arrow would be like this. Okay, rest they ionize in the same fashion as that of H2SO4. Same would be for the oxalic acid as well. Okay, just its structure is like bit different from them, but the reaction would be exactly the same. 2 hydrogen atoms, okay, they would get released. Okay, they would form 2H plus. This 2H plus would be taken up by the 2 water molecules. Okay, 2 water molecules, I have written it exactly the same. Since it is also a weak acid, double-headed arrow, it would result into the formation of 2H3O plus. Okay, 2H plus getting combined with 2 water molecules, 2 hydronium ions, and the remaining part would be C, this one, COO, and the bond is between this carbon atom. Okay, here it would be negative charge, here it would be negative charge, so it would result into 2 negative charges. Okay, here see 2 negative charge, 2 positive charge. Okay, So the charges are balanced here. So charges are balanced, no need to see here. Okay, 2 positive charges, 2 negative charges, balanced. 2 positive charges, 2 negative charges, charges are balanced. Okay, so in this way they ionize to form, see here, 2 hydronium ions. Okay, that's why they are dibasic. Now let's see how this phosphorus acid H3PO3, okay, this ionizes. So you can pause here and try to write the ionization equation on your own. Okay, I hope you have resumed back. So in this case, now if you would have paid attention and if you would have applied your logic, okay, some logic, so you would have written the right equation, because I have already told you that this H3PO3 is a dibasic acid, right? Dibasic, which means it would give only 2 H3O plus ions, correct? So here, if only 2 H3O plus are going to be formed, so you would have applied the logic that from here also only 2 H plus ions would be given up, right? Given off from the H3PO3. 2 H plus ions would be catched by 2 water molecules, okay? And since it is also a weak acid, okay, leave about this part. I don't expect from you that you would write the arrow, correct? Because this is a weak acid, like same like that of H2SO3, H2CO3 and oxalic acid. This is also a weak acid, okay? Not that weak, but yes, it is a weak acid. So it would have this double-headed arrow. Now, what would remain here? See, out of this 2H plus, only 1 H is remaining, P is remaining and O3 is remaining, okay? Now, these 2 charges, so H, P, O3, right? And it is having 2 minus, okay? Now, you can remember this thing from the trick, because PO3 has 3 minus, okay, charge. So if 1 H plus is with it, what would happen? Plus 1 minus 3 is minus 2, right? So HPO3 would have minus 2, correct? So in this way also you can derive the charge, and then after that, or else you can just make the charges balanced. Okay, so here 2 plus, here 2 minus. Okay, very clear. Now see, but this balancing the charges part, okay, you should only do when you are writing the ionization equation in one step. Okay, because just now we have seen when we are writing it in more than one steps, so it is not always that the charges would be balanced. Okay, so you only do this when you are writing the ionization equation in one go, in one step. Clear? And also when you do this, when you find that the other side doesn't have any charges. Okay, so I would suggest you that better not use this second trick, okay, which seems to be simple, that just balance the charges. Use the first one. Okay, the first one is based on your knowledge as well as some logic. Okay, so here you know that particular polyatomic anion has some charge, then you are just adjusting the charge with it, okay, with the other ion. So now let's come back to this. So you now can see 2 hydronium ions are being produced. Okay, so it is a dibasic acid. Now why is this happening? Because out of 3 hydrogen atoms which this phosphorus acid is having, only 2 hydrogen atoms are ionizable. Okay, the one hydrogen atom, remaining hydrogen atom, is not ionizable. Okay, so you can see the structure. From the structure it would be clear for you how only 2 hydrogen atoms are ionizable. See, this hydrogen which is attached to oxygen, this hydrogen which is attached to oxygen, okay, these 2 hydrogen atoms are allowed to let go, okay, as H plus ions. This hydrogen atom which is attached to phosphorus, it is not allowed to get lost, okay, as H plus ion. So since these 2 are allowed to go as H plus ions, they combine with 2 water molecules, form 2 hydronium ions. Okay, so this is the reason behind why the H3PO3 is a dibasic acid. Okay, here. So it can be asked in your exams, why H3PO3 is dibasic acid. Similarly, why acetic acid is a monobasic acid. Okay, this can also be asked. Okay, so I have already told you the reason of both of these questions. Now this acid, okay, H3PO3, we call it as an oxy acid of phosphorus. Okay, now what is actually oxy acid? Oxy acid means the acids which are having oxygen, hydrogen and some other element. Okay, so it's very easy. Now you can tell me that H2SO4, okay, it is also an oxy acid having oxygen, hydrogen, but now it is oxyacid of which element? Sulfur, right? Same way HNO3, okay, it is also the oxyacid, okay, because it is having oxygen, hydrogen and some other element. Now it is oxyacid of which element? Nitrogen, okay. So these are examples of some oxyacids: H3PO3, H2SO4, HNO3. Next, let's see the example of tribasic acid. So tribasic acid is an acid which is having basicity 3 because it's simply giving 3 hydronium ions, okay, by the ionization of its one molecule in aqueous solution in water, when it is dissolved in water, okay. So here is the example of tribasic acid H3PO4, okay. In this case H3PO4, now you would try writing its ionization equation, but just giving one more hint, this is also a weak acid, so arrow would be in this way. So you can pause here, try to write its products, okay, on your own. Okay, so I hope you would have resumed back. So see, H3PO4 and water. So as I have told you, it is a tribasic acid, so it would produce 3 H3O plus, right? 3 hydronium ions. So for 3 hydronium ions, it should be 3 water molecules. And same way, these 3 hydrogen atoms are now being lost, okay, as 3H plus. These 3H plus are getting patched up with 3 water molecules forming 3 hydronium ions. Now this is clear to you. Now what is remaining? PO4, okay. So I have told you already, what you have to do is you simply first of all learn all the charges, okay, which are present on the polyatomic anions. Charge of SO4, which is 2 minus, SO3 2 minus, PO4 3 minus, okay. So there would be a list of charges, okay, you can find in your book, and you learn all the charges which are present on the polyatomic anion as well as monoatomic anions. Same case, polyatomic cations as well as monoatomic cations, okay. So it would be easier for you, then it would be a piece of cake for you to write the ionization equations, okay. So let's now see here, it is also getting dissociated like H2SO4, which ionized in 2 steps. So this H3PO4 also gets ionized, okay, in 3 steps. Now you can again try to write these 3 steps on your own. Let it be wrong, you would learn from it, okay. So pause here, then again resume back. So this H3PO4, first step would be, it would react with 1 water molecule, same like H2SO4. It would give up its 1H plus. 1H plus would combine with, okay, 1 water molecule, form H3O plus, and this would be the sign, okay, reversible, because already it's a weak acid, and when we are writing it in steps, we have to always use this sign, okay, reversible sign. So here H plus is being added into water, forming H3O plus. Now what's remaining? 2 hydrogen, okay, H2 and PO4 as it is. Now our trick, what is our trick? PO4 has 3 minus charge. There are 2 hydrogen atoms, so 2 plus charge is also there. So minus 3 plus 2 is minus 1. Okay, so you can just write minus here. So H2PO4 has minus. Now what we have to do is, we have to take up this again, because this H2PO4 minus ion would further ionize. Okay, further ionize, how it would ionize? 1H plus at a time. Same way, 1H plus getting patched up with, getting bonded with water molecule, forming 1H3O plus, and then what would be remaining? 1H and PO4. Same 1H PO4. Now same logic, PO4 has 3 minus, right? Here it is 1H, so 1H has H plus, right? So plus 1, so minus 3 plus 1, what it would be? Minus 2. So here it would be 2 minus. And remember, when you are writing the charges, you first write the number and then the sign. Okay, don't write it minus 2, write it 2 minus, 3 minus, okay, in this way, 2 plus, 3 plus. Now again, this ion would come back here, HPO4, 2 minus, it would again lose 1H plus, right? Again H3O plus is formed, okay, and what would be remaining now? PO4. Now we already know PO4 has 3 minus charge, so we have simply written it. So in this way you can clearly see here, see 3H3O plus ions are getting formed. Okay, so when we would write the net equation, so see this H2PO4, H2PO4 minus would get cancelled, this HPO4 2 minus, HPO4 2 minus would get cancelled. You can sit and slowly you can observe which terms would get cancelled. I am directly telling you. So what would remain? See, from this H3PO4, so net reaction, H3PO4 is there, 3 water molecules, this reversible arrow, then 3 hydronium ions, okay, and then what's remaining is PO4 3 minus ion. Okay, so this is the net ionization equation out of this all the 3 steps. Okay, now moving ahead to the very interesting concept, okay, and very important topic in context of your practicals, okay, or when you would work in labs. This thing you have to always remember, how to dilute acids. Okay, now what does this mean? What is the meaning of dilution? Dilution simply means if you are given an acid, okay, you are adding water to it. Okay, this means that you are diluting it. Very clear. Now how to add water in acid? So you would say that, oh, it's very simple now, like all other things, how we add water in any other thing. So in the same way we would add water in acid only. And if you would do same, if you would directly add water in acid like that only, so the acid would just splash out, container may break up, and it would be very much dangerous. Okay, so don't try at all this thing. Now why is this happening? And then how we should dilute. Okay, so first of all, let's see how we should dilute. Okay, we should dilute, or we should add water in the acid exactly the opposite. Okay, we should actually take water in a beaker and then we have to add acid to water. Okay, now for this you can have a simple trick. We are going to learn the reason, but instead when you are doing the work in lab, I am also telling you the trick to remember this thing. Simply acid to water. First in alphabets A comes, capital A, and then W comes, right? So acid to water, A to W. Very clear. Now we have to add acid to water in small amounts, okay, and we have to stir constantly. Okay, if this is my beaker, I would stir, okay, the solution constantly. Now why is this happening? When we are adding water to acid, what is actually happening? So that the acid is getting splashed out, container may break, because water and acid molecules react with each other, and after this reaction heat is evolved. Okay, the result of this reaction is heat is evolved. So this is an exothermic process. Exothermic means, exo means like out, okay, thermic means like something related to heat. Okay, so heat is given out or heat is evolved, and this heat, what is happening? Okay, this heat is in turn moving, this heat would move out, right? So this heat in turn is heating up the acid. Okay, and after heating up the acid is getting boiled. Okay, due to which, now you only just try to visualize if acid is getting boiled. Okay, so what would happen? After some tremendous boiling of acid, the acid may splash out, right? Or the container may get breaked. Okay, now in order to avoid these things which are very much dangerous, what we have to do, I have told you, you have to add acid to water. Okay, acid to water very slowly, and we have to continuously stir it. Now what is happening in this case? When we are adding acid to water, again water acid reaction is taking place, heat is getting evolved, but now this heat is being absorbed by the water. Okay, and water has very good ability to absorb the heat, okay, as compared to acids. So it just very nicely absorbs the heat, but after absorbing the heat, it doesn't get boiled up, because the heat which is evolved in this process, it's not enough to boil the water. Okay, so water doesn't get boiled up. So if water doesn't get boiled up, what happens is just you would feel the beaker, it's getting warm. That's it. Nothing else. So water remains as it is. It is not getting boiled up, so solution is not getting splashed and all those things. And our acid is also getting diluted because we are adding acid to water, so in turn the solution is of acid and water. Okay, so our acid is also getting diluted in this way. Okay, now here this thing you have to always take care. Now what about adding in small amount? Because the reaction, why we should add in small amount? Because the reaction would take place at a smaller pace, okay, at a smaller extent. So if the reaction is taking place at small extent, which means less amount of water molecule, less amount of acid are reacting, so less amount of heat is evolved. So it is good, right? If you would directly add acid, okay, in large amount to water, what would happen? Large amount of heat would be evolved. Now in this case, water would not be able to absorb all that heat, okay, and the solution may splash up. So that's why you should add in small amount. This also you have to remember very clearly. And while adding, you have to stir the solution constantly. Now why you have to stir? The logic is very simple. See, the heat is getting absorbed by the water. So what would happen when we are stirring the solution? So the part of water which has absorbed the heat, now we are stirring. So after that, this part would be moved to some other place. Another part which hasn't absorbed the heat, it would come. Okay, so there would be an even absorption of heat. So uneven absorption would be avoided, but that's it. So simply we have to just stir the solution constantly so that the heat is getting absorbed evenly in the water. And when it is getting absorbed evenly, it would be more efficiently absorbed, right? And with this, we have reached the end of this video, and I hope you would have enjoyed learning with me. You would have understood all the concepts, but please do let me know in the comment section whether you have enjoyed, whether you have understood the concepts or not. And we will meet in the next video with the remaining concepts of this chapter. So as you all know, LearnoHub matlab free hai par best hai. So till then, bye bye, take care and have a great day.